Hi everyone, this is Nathan with the team from Hong Kong University of Science and Technology. Today, we would like to showcase our idea about a smart track and trace system for a smart and sustainable wet lab community. As we know, laboratories and research institutes are the major places for cutting-edge scientific exploration. Hundreds of millions of research papers were born here. Behind this glorious achievement were three unsustainable facts. Firstly, the reproduction of the experiment is low. The replication is difficult and time-consuming. Besides, error tracking is complex, with unexpected accidents happening. According to the research from biopharmaceutical company, more than 60% of redo experiments barely match with the previous successful results. Another survey from MD Anderson Cancer Center indicates that academic researchers have trouble duplicating others' published results. Junior faculties and researchers often do not resolve discrepancies and turn out to publish conflicting reports. Secondly, the experimental data are too costly to meet analysis needs. Meanwhile, many precious field attempts have not been effectively explored or analyzed, but are directly ignored or discarded. Unlike the debug process in the computer science or engineering domains, the lack of valid raw data and unnoticed intermediate products make the synthesis experiments harder to check thoroughly. Therefore, redoing the experiments has become the popular way to iterate, which relies too much on chemical consumption. Thirdly, based on a study from American Economic Review, the global experimental innovation efficiency has encountered a bottleneck. When Moore's law is doubled, the experimental personnel investment must be multiplied by 18 times. It turns out that the labor-intensive style of R&D research pattern, which has not revolutionarily changed for centuries, is limiting creativity and productivity. Besides the literature research, we also interviewed our university members to collect the pain points of the wet lab, including the frontline students, lab managers, and professors. The survey data shows that timely stock tracking of intermediate products, and automatic data recording are the top three demands or issues. To solve these unsustainable problems, we have proposed an IoT and AI-based solution, Smart Track and Trace, X-Tray. Our solution consists of both hardware and software. It combines the RFID reader, multi-sensor, and SaaS platform for real-time data tracking of chemicals and related users. This tracking is seamlessly through the whole loop of chemical usage, thus can provide safety and compliance to all stage users. With the data collected, we can further explore the chemical sharing function within and among different R&D communities. So how does it work? Let's have a look. The core product is a hardware X-ray. It includes the RFID reader with sensor and an original design control board. The use of our product is quite simple with three steps. Firstly, stick the RFID tag to each new chemical. Secondly, put the tagged chemical onto X-tray, fill in the information once and for all. Thirdly, take and return the chemical as usual. Which change and user ID will be associated while an RFID reader in each action. Our device can achieve 1 to 10 vessel detection, Wi-Fi data transmission, and local data backup. The unnoticeable and seamless tracking will least affect the user's normal behavior. Therefore, it is suitable for chemical inventory management for individuals, departments, and central authorities. Based on the GHS standardized safety codes, we have programmed each label with corresponding categories. When there are two tagged bottles that are not suggested to put together but gathered, the alarm will be triggered in terms of the red LED blinking. buzzer beeping, and client email notification. It can also send a reminder message to users for the chemical nearly expired. You may also ask, how can we handle weight tag matching of multiple chemicals placed on the same tray? An algorithm is developed for this problem. When the backstage detects that the weight is not stable, it considers that an operation event occurs. The system will mark the X tray with pending status until weight to be stable. Once the weight is stable, the system calculates the container weight change using the difference between the current stable weight and previous ones. Both the tag ID recorded during and before the event are used to match the operations container. In this way, we can mitigate the weight drifting and other matching issues. These are software interface in both mobile and desktop views. The UI is a storyteller that provides all angles to view the information, which is very different from traditional lab management scenarios. It can help lab users, managers, and PIs, showing rich usage information. For example, the history data of each chemical are shown with a line chart with a time weight plan and a bar chart with a weight. To display the remaining amount of the chemical, the ring chart is adopted. The software system's final goal is to make seamless integration into researchers' daily work, bringing great convenience to end users, and increasing users' active engagement and stickiness in return. To achieve the goal, gamification is introduced to make the software fun to watch and engage. As shown here, users can interact with the dashboard, dragging the timeline slider to see the chemical usage and history in different time slots. Meanwhile, for user history, the heat map is used for contribution record. When a user swipes the RFID and records the data, the activity box will be filled with color, indicating a daily mission accomplished. The activity record can bring the users a sense of achievement and engage them in our system actively. Simultaneously, when users continuously input data from the real-world operation, the database will grow days and nights for AI-guided big data modeling and processing. After research data is collected from the hardware and software system, some essential data and records must be safely stored on a trustful platform with adequate security assurance. We will enable the users to upload their lab notes or experiment results to public blockchain to ensure authenticity and originality. These proofs can be verified anywhere in the world and do not need any additional trust. Furthermore, data collected and stored on the blockchain can be used to build their own customized research NFTs. We have invited several research students trying our proposal system in their daily experiments. Compared with the conventional management method, users no longer need to go to the lab for the on-site check. Our system can decrease the chemical searching time from 20+ minutes to less than 5 minutes. Besides, the inventory check, notification, and cooperation functions are online-based and user-friendly. Here comes to our conclusion. In this project, we proposed a smart tracking tray system for chemical management. We have already received positive feedback from pilot tests in several labs at HKUST. The system benefits various lab users in their daily work and improves their working efficiency. The X trays can be put at a specifically allocated area to collect the inventory's data. Chemicals trays can be seamlessly monitored from warehouse to individual labs, eventually recycle points. In the long run, we believe it will play an essential role in promoting the efficient use of lab resources, including timely chemical inventory checks, sensitive and dangerous goods monitoring, and sustainable sharing of unused idle substances with blockchain encryption. Last but not least, this is our shining key. Thank you for your time.